For topic 4, we're going to talk about something called effective annual yield. Okay. Effective annual yield is kind of a special thing because it allows you to shop around for investments or loans with different terms. Okay. So this can sometimes be really confusing. So, as a legitimate human out there in the real world, looking for the best investment or looking for the best loan, I sometimes have to do some work. Okay. So you're not necessarily going to have the same terms on a loan or investment depending on where you go. Okay. So you could have, let's talk loans, for example. You could have loans with different time frames, different interest rates. Okay. You could have investments with different compounding periods, different interest rates, different time frames. Okay. So how do we find a way to compare loans or to compare investments? Okay. So this is where effective annual yield comes into play. Okay. So effective annual yield, this is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subjected to compound interest at some other stated rate. Okay. So let's just say you've got three different investments. Okay, so three different investment opportunities. They have different compounding periods and they have different interest rates. How do we find some common ground? How do we compare these? Well, we would find the effective annual yield for each of these three different investments, and that basically converts your compound interest situation to a simple interest rate, and then you just have to compare those simple interest rates. For an investment, you want the highest possible effective annual yield. Okay. Now, if we were talking about something more like a loan, you would want a lower effective annual yield because you want the lowest possible interest rate then. So again, this just gives us a way to shop around for loans and investments, okay? It converts everything to an equivalent simple interest rate, assuming just 1 year's time, okay? So the formula, now I've mentioned this in, I think, most of the videos for 8.3 and 8.4, especially if you're in the online class, start creating your own formula sheet. If you don't have printing capabilities and you cannot print the formula sheet that I have in Moodle, start creating your own. This is another formula you would want to add to your list. So think Y for yield, okay? So effective annual yield is Y equals 1 plus r over n in parentheses raised to the n power, and then we subtract 1. And what that does is it takes the terms on a compound interest loan and it converts them to a simple interest rate. So we can kind of compare from there. Okay. So let's look at an example here. Example 5 says determine which account is better by calculating effective annual yield. So in this case, we're looking at an investment. Okay, so assume this is some kind of investment. You have two different opportunities, but which one's going to benefit you the most? Okay, so what is the effective annual yield in an account that pays 8% compounded quarterly? Okay, so that's the first situation here. We have our interest rate and we have our compounding period. Okay, so R is going to be 0.08. And N quarterly would indicate there's 4 quarters in a year. Interest is going to be calculated 4 times a year. So N is 4. So we get Y equals 1 plus R 0.08 divided by 4 raised to the N power. So raised to the fourth power minus 1. So let's go to the calculator. And then sometimes you'll see books where they take this whole thing and they multiply it by 100. I'll show you why we would do that potentially. So let's go to the calculator. So let me clear this out so as not to confuse. We want to go in parentheses and then 1 plus the interest rate, so 0.08 divided by the compounding period, which is 4. We're then going to raise this to the compounding period, so to the fourth power. And then we want to leave the exponent, so just hit the right arrow and then type in -1. And what that does is that gives us a simple interest rate, but in decimal form. So sometimes you'll see books take an effective annual yield formula like what we have, and then they'll just multiply it by 100. And all that does is kind of convert it from decimal form to percent form. And we have 8.243216. Let's round this 2 decimal places. So I would say we would need a simple interest rate of 8.24% to get the same amount of money. So 8.24%. So Y equals 8.24%. And you do want to write these as percents, okay? So this is the simple interest rate that would give us the same amount of money in 1 year. All right. Now, for part B, it says, what is the effective annual yield for an account that pays 7% compounded daily, non-bankers rule? So remember, bankers rule, 360 days. Non-bankers rule, 365 days. So since we're not using the bankers rule here, we would use n equals 365. So R is 0.07, n is 365. So y equals 1 plus 0.07 divided by 365 raised to the 365 power minus 1. And then again, sometimes you'll see books take this whole answer and then multiply it by 100. That's fine by me. So let's see what y equals. On the calculator, we take in parentheses 1 plus 0.07 divided by 365 raised to the 365 power. We want to leave the exponent and then subtract 1. We get a decimal. We multiply it by 100 and it'll convert it to a percent. And we get basically 7.25%. So 7.25%. So that would be kind of the same thing. So the y equals represents the simple interest rate that would give you the same amount of money in 1 year. Okay. So under the same circumstances where we have the same interest rate and then 1 year, we would need, or not the same interest rate, given the circumstance, I need to really stop and slow down. Given the circumstances here where we have 7% interest compounded daily, the equivalent in the simple interest world would be an interest rate of 7.25%. So we would need a higher interest rate to get the same amount of money in the same time frame. Okay. So then it says which account is better. Assuming an investment, A is better. Okay. With an investment, you want the highest effective annual yield. So we have a way higher effective annual yield by almost a whole percent. Okay. So A is going to be much better here. If this was a situation where we were thinking like loan, it would be B because we would want the lower effective annual yield. Okay. So that is effective annual yield. Again, it just takes the circumstances that you're dealing with compound interest, converts it to basically an equivalent simple interest rate that would give you the same amount of money in 1 year. It's not an equivalent rate. It gives you a rate that would give you the equivalent amount of money in 1 year. Okay. So that's it for 8.4. The next section, we're going to talk about annuities and savings plans. Okay. And so if you kind of think back to these questions where we were finding P. So let's say like in part A and part B of example 4, we knew we had this future goal. For part A, we needed $25,000 in 18 years. For part B, we needed $50,000 in 25 years. So today, we would have had to come up with either a little over 11,000 or a little over 14,000. For a lot of us, that's not reasonable. A lot of us don't have 11,000 or $14,000 sitting in the bank. So we could never get this amount of money in 25 years or 18 years because we just don't have the current cash now to invest. So when we get to section 8.5, we're going to talk about a way around that. There's something called an annuity that lets you make smaller deposits on a regular basis so that you can achieve certain future goals. And that becomes much more realistic for most of us workaday types. Okay. So that is compound interest again. In the next section, 8.5, we'll talk about investments and saving plans and savings plans. Okay.